All right, so we talked about the shape of long bones. Now we're going to talk about all the other ones kind of together as a group, which are going to be short bones, irregular bones, or flat bones. And the way that they're formed, and we'll show a little bit of pictures later about how bones are formed, is that you start out like this where you have two membranes. And then what are membranes that form that have to do with bone? Right, so we talked about periosteum. So if it's on the outside, you can have two layers of the periosteum. And then they're going to, it starts out like here, then you're going to have compact bone on the outside and then spongy bone on the inside. So there's no diaphysis or epiphysis. So they can just do their growth just from right at the edge of this, between the compact bone and the spongy bone. And then the spongy bone on the inside is called the diploid on the inside. All right, and then what kind of bone marrow are we going to have in here? Red bone marrow. So remember, long bones have an epiphysis and a diaphysis, and all the rest don't. Short bones, irregular bones, flat bones.
And then you said the growth occurs on the short, irregular, and flat bones between the spongy bone and the compact bone?
Yeah, I mean, it's called membranous. When we talk about bone growth, we'll get into some more details about that. But it's either, bone either is formed in cartilage, or there's enchondral bone formation, or membranous bone formation. So flat bones and all those other ones are membranous bone growth, and we'll talk about that a little bit later. So it starts out where you have red bone marrow. In the infants is found in all the medullary cavities of all the spongy bones. And then as you come into an adult, it's going to be more of the flat bones and the head, a little bit on the proximal femur and humerus, and then, like I said, the ilium, some of the bones of the spine, some of the ribs. Okay. So in the infant, pretty much anywhere that there's spongy bone, because even long bones we talked about have spongy bone more at the epiphysis and the end of the diaphysis. So long bones are going to have spongy bone up in this area here, and they're going to have compact bone down here. So in an infant, you may have red bone marrow in the epiphysis and then near the epiphyseal plate. Then as you become an adult, it focuses more on these areas here where you have shows the red bone marrow. So some of it's in the skull, some in the ribs and the sternum, in the pelvis, the spine, and then the proximal femur and the proximal humerus. All right, so now pretty much, okay, we talked about macroscopic bones, we talked about long, short, we talked about membranes, we talked about the cells, osteoclasts, osteoblasts, and osteocytes. So now we're going to talk about this, the osteon or the Haversian system. So what that is the building block of the way bones are built in the compact bone. So it's a structural unit of compact bone. So let's say if you're going to talk about a brick wall, what's the unit that you build the wall out of? It's bricks. So it's a little more complicated than that, but that's basically the different units that we're going to use to build the whole bone. Okay. So there's different terms that we're going to talk about when we put the system together. So at this point, we'll just talk about these words and talk about what they mean, and then you'll see a picture and it'll make a little bit more sense. Okay. So what does the word lamella mean? It means layers. Okay, so when we're talking about the lamella in the bone system, it's going to be layers. Kind of like the rings on a tree. Right? So the lamella are going to be weight-bearing column-like tubes that are mostly collagen. Okay. And then the Haversian canal or the central canal is going to be a canal inside of that tube. Remember I was talking about before that we're going to have ways to get blood in and out of it and nerves. Okay? So there's going to be tubes going up and down through the lamella, and that's going to be the Haversian canal or the central canal. So that's going to contain blood vessels and nerves. And then to get the blood from the outside, if all we have is columns going up, canals going up and down, could we get all the way into the middle? No, you have to have ones that go at right angles to that, right? So that's what these are going to be, these Volkmann canals. So they're at right angles to the central canal so that things can penetrate deeper into the bone. And so again, they're going to contain the same things: blood, vessels, nerves. Okay, so it's going to start from the periosteum and then it's going to work its way in. Okay, so you have the vertical columns, which are going to be the Haversian or central canals, and then you're going to have Volkmann's canals, which go perpendicular to that. And then, like we mentioned before, you can have osteocytes, and those are going to be the mature bone cells. Osteoblasts grow up to become osteocytes. And then lacunae, that's the empty space. Okay, so that's the small cavity in the bone that's going to contain the osteocyte. Remember before, it's like the osteoblast is going to be creating bone and forming bone, and it forms bone all the way around itself, just about, so that it's blocked in. And so that's the lacunae, is this empty space inside of this bone system where the osteocyte is. Right? And then the canaliculi are little smaller canals that actually go down to the level of the osteocyte, where things can go in and out of the cell, or to the lacunae. So those lacunae, it's not completely sealed all the way in. There's little tiny holes. Okay, because if those cells are still going to be alive, they're still going to need nutrients, right? So there has to be some connection to it. Right? And they're going to connect to each of the other lacunae, and then also to the central canals. So then, again, in the long bones, when we're talking about the mid portion of a long bone, like in the middle here, where you have a canal, you have the central canal, that's where the yellow bone marrow is. And you might have some red bone marrow up in the other parts, especially in infants. All right, so this right here is the osteon, or the Haversian system. Remember we said that's going to be the unit that this whole compact bone is going to be built from. So just think of it like in these Roman buildings, or Greek, you have these big, tall columns, right? So that's what these are. Osteons, they're columns. Instead of in the buildings, there's space in between the columns. In this case, the columns are right smack up against each other. So the shaft of a long bone is a series of a whole bunch of columns together. Right? So those are these columns going up and down. And so then what did we say those columns are built of? They're built of layers, right? And then what's the word we're going to use for layers? No. Okay? So now we're taking the picture of this. Here's the whole big picture of the bone right there. We're taking that and breaking it down to this level. And here's the columns going up and down. Those are the osteons, or the Haversian systems. Those are the units that we use to build the bone. And then now we're looking at each individual column. And again, it's made up of rings, just like on the rings of a tree. Right? And then we said that inside of those lamellae, here's where the osteocytes are. So they started out as osteoblasts, right? They make the bone, they secrete the osteoid and everything, and they grow up and become osteocytes, and they've enclosed bone all around them. But it's not completely sealed. That's where you have these, the lacuna is the opening where the cell sits in itself. So the lacuna is where the opening that the cell is in. And then what are these other little tiny passageways? Yeah, caliculi.